So in Chapter 4, Section 6, we've been dealing with exponential and logarithmic equations and looking at derivatives. On the first one, they're asking us to come up with the exponential equation that's in this form given a couple points. I'm going to, on the supplement, I'll show algebraically how to do it, but I also figured that I could show you using regression and how you would use regression on Desmos. So we're just going to input the points, and if I'm trying to figure out what that equation is and it's in this form, I'm just going to say my y1s, the symbol for regression is the tilde. And so I have some c value I don't know, and it's an exponential raised to the, let's see if it'll do all of it, k x1. And so when I do that, I get this nice graph that goes through it. It tells me that my c value is 8 and my k value is negative 0.0522. So the same thing that's the answer is. Again, I'm going to show you how to do it algebraically, but you could always verify doing a regression on Desmos. Also, to look at number 4. So when you're looking at a half-life of something, the equation for a half-life would be you have your amount left over equals your initial amount. It's a half-life, so every so often it reduces by a half. So it's some time amount divided by whatever that half-life number is. So I'm going to call it years for half-life. So here's the number of years. T stands for the number of years that has happened. This is our years it takes for it to completely go to a half. So like if this was 10, if t was 10, it'd be multiplied by 1/2 to the first power. So how many years for a half-life is your denominator? How many years has happened is your t. Since we're dealing with half-lives, it's a half. I is your initial amount, and a is your amount left. So with this one, we could type in our percentages. So I have 96.73%. My initial amount that I start with is 100%, so 1. I know that my t, they said, is 1 year, and I don't know what that bottom value is. So that's what I'm trying to figure out, the years for a half-life. So I'm going to call it x. Now, this is something that Desmos cannot solve. But if I say this is my y, and I say my y equals 0.9673, then I'm just solving to find where these two things intersect. And so here's my line. This is years. I see it following there, and I see the intersection right there, which is 20.8 years, rounded to 1 decimal place. So in the supplement, I'll show it how to do it algebraically. But again, we can use Desmos to help us out. And last one I thought we'd look at is number 9. So with number 9, we have these two equations, and we're trying to find the year in which timber should be invested to maximize present value. So A represents the present value. It has this V equation, which they give us up here. Both of these equations are affected by time. So if I wanted to find where it maximized, I could put these together and then take the derivative of them. So we got e raised to the minus 0.87 square root of, I'm going to call it x. So that's what v is. But I'm going to multiply that by this, because there's my v, I just inputted it. And then I also have this e raised to the negative 0.05x. So I'm going to get an equation that I should have. T responds to the year, corresponds to 1990. All right. So here's my equation. Let's check it out. All right, I don't see a whole lot of it. Thinking that this stands for years, my x is years. Let's see if we go out a little bit, maybe 100 years. The a value is amount of dollars. Looks like there's an initial amount of 80,000, so maybe I just need to go up way higher to get an idea of. So here's 100,000, maybe a little bit higher. At least I can kind of get an idea of a picture, so I have some picture going on here. Again, I don't know how high it goes, but this is what I'm trying to maximize. So I'm going to go up a little higher. Let's just get rid of all this and make it have some more zeros. Oh, there we go. So I have some maximum value. And I find that's going to take 76 years if I round it up. Well, 76 years from that 1990 is 2066. But we can look at doing this one by hand, finding the derivative. It looks like it's a product. So I would just be using basically a form of the product rule. Maybe some chain rule in there as well. But I'll make some supplement for those. But this should get you started on that chapter 6.